let me get started. Cool. I have the power. So if I screw up all evening long, at least that worked. So I'm Gunnar. Maybe some people know. And I'd like to give you an introduction tonight on WebSockets. Give you fairly high-level overview, cover a ton of slides, have 4 or 5 demos possibly lined up, depending how much time we have. I gave this presentation at Spring 1 together with Russ and Soyanshev and Chris Beams. Updated it slightly, put it into a keynote format, and hopefully help you understand what WebSockets are, what you can do with them, and where the limitations are. So, I'm working for SpringSource, division of VMware, or as we are now in this transition phase of, I don't know how many people got the news that kind of like EMC and VMware decided to spin out a big chunk of EMC and VMware people into its own little independent entity. So we will join actually the Pivotal Labs folks, among other things. Green Plum from EMC, so big data folks. We have the vFabric side. So I think it's like 1,400 people that will join this new organization. So that will be kind of exciting. So, but for right now, still VMware. So I'm committed on the Spring integration framework. Have a few pointers on that during my presentation towards the end. Also committed sporadically on the Spring AMQP project, and also have been the creator on the Cloud Foundry Maven plugin. Twitter, LinkedIn, I'm blogging occasionally. Probably should do more. Haven't done that lately too much. Although on the SpringSource blog, there are a few postings. All right, objectives for our today's presentation. I would like to kind of like survey the current situation in the WebSocket world, where we are, what you can do, etc. Presentation is not so much on like the hardcore, like the core stuff. I'm kind of go on what's applicable generally in the WebSockets world. We will have some special focus on JVM and Java. But I'm probably not going too deep in some of the code samples, particularly, especially in the Java world. Things are changing quite rapidly still. But I hope that by the end of the presentation, you will have a good understanding about the WebSockets landscape and how you potentially could use it down the roads in your own projects. And yeah, little special emphasis about Java. But even though, is anybody in here that does not Java? OK, so it doesn't apply. But even if you wouldn't, I think this presentation should still have some useful things. Slides, they should be on SlideShare right now. The exact same version is here, so I set that up. Samples are on the Git repo by Chris Beams, Bitcoin RT. It contains almost all samples, and I will commit. I have a couple of fixes I did. I will commit those later tonight, so that everything is updated. WebSockets. Who has heard of WebSockets and has kind of like a? Who has never heard of WebSockets, or has? Okay. So basically, the idea is that some web applications, not all, but some, probably moving forward more, will have a need for two-way communications, rapid updates. Everybody likes to have information now. Remember the days when it was OK for us to wait 10 seconds to get a response back from a UX perspective. Now everybody needs to be there right now. And we had AJAX, Comet techniques, but they're to some degree rather inefficient. And WebSockets kind of like has the promise to solve that situation. So when we do certain polling techniques right now in current applications to get data from the server on a rapid basis, kind of like this imaginary real-time approach, we may end up with too many connections, lots of overhead, sending all those cookies back and forth, etc. And just too much of a burden for the client itself. some examples where you might using it: trading, chat, gaming, kind of like the typical examples you had also with AJUG to some degree. Collaboration, visualization, and that's kind of like the goal from the WebSocket protocol itself. The goal of this technology is to provide a mechanism for browser-based applications that need two-way communication with servers that does not rely on opening multiple HTTP connections. So, and I will talk about the WebSocket protocol itself more specific in the ongoing slides. So having that two-way communication, that's basically what WebSockets tries to solve. Over single connection, it's basically a layer on top on TCP. It is not HTTP, but uses HTTP to get the communication started, and provides extremely low overhead down to the smallest communication could be 2 bytes. Basically, that's all that's being exchanged per message. Just a quick introduction on the HTTP handshake. When you do open up a WebSocket connection, the important takeaway is basically this one-on-one switching. So basically, that's kind of like the indication that you're established a WebSocket connection. Has been in the HTTP spec, but never really used. So it's kind of employed for WebSockets to basically use HTTP to jump over into that into the WebSockets connection. And this is kind of like an overview of the frame. So that's kind of like the data that's being transmitted over the wire, and I will talk about those a little bit later, more in detail. And as our sample in order to explain WebSockets, in order also for you to give opportunities to play with WebSockets, we basically created a project called Bitcoin RT. It basically visualizes Bitcoin transactions. Who in this room does not know what Bitcoin is? Cool. Basically, Bitcoin is digital money. So it's kind of like a peer-to-peer generated money transactions. Everything is in the open, and it's basically used to, basically you can pay with it. It's almost like virtual money on the internet, and pretty much no banks are involved, kind of like in a pure peer-to-peer fashion. If you later on check on the link, it gives you a quick video on what Bitcoin is. But it's kind of like, for us, it's at least similar to Twitter. It provides us lots of free data for visualizing real-time data. And also, the service provider we're using has a WebSockets API that we could tap into. And it's inspired by the original Bitcoin monitor. So let me jump into that. Bitcoin monitor. So that's basically the original data, and those are actually real-time transactions that's happening right now. However, they're using long polling for their data transmission. Also, for our example, we used a visualization library called D3.js. I mean, we only tapped very mildly into that library, very primitive in a sense. However, take a look at the library. Freaking awesome. I mean, you can do all kinds of crazy visualization, and does not use, and it's all in HTML5. So it's pretty cool stuff there. Using MongoDB for the persistence of our sample, and screen. And we also provide multiple implementations of this scenario. So we have one for Node.js, which is a JavaScript asynchronous framework that uses JavaScript on the server side. We have one which uses pure WebSockets. We have one that uses Sock.js, which is another library on top of WebSockets that provides some fallback options. I'm talking about that also later. We have Java plus Tomcat, using Tomcat's native WebSocket support. We have one sample using Atmosphere, which is a Java-based framework for providing not just pure WebSockets, but also various fallback options. And then one Java plus Vertex. And Vertex is it's basically this a JVM implementation of Node.js. So you can do the asynchronous programming model on the JVM with Java as well as other languages as well. As I said, samples on GIP. And let's get into the Node.js demo. So to just give you an idea of what the traffic looks like on the wire. Let me start up Node, the sample. All right. Should be starting on port 1337. Let's refresh. Now we should see some transaction coming here. So nothing super exciting, but what I would like to show you is the see the developer tools, network. Let me refresh, and we should see no long polling in that regard. However, we should see the switching protocol happening on the downside here. And when you're using Chrome, you can then also tap into the details of the WebSocket, of the data that's being exchanged. So here you see the individual messages, or more precisely, this is the you can tap into the payload of the exchange messages, which in this case is JSON. So you see the trades, date, price, etc., what's being exchanged. You see the let me just basically when we establish the connection, basically the upgrade to WebSockets, and then that it happened, and then basically the status code 101 switching protocols. So I talked a little bit about the benefits of WebSockets. So we have, it's more resource efficient. It provides lower latency of data. Conceptually, it's a simpler product, much simpler to set up. And I put that little asterisk in there when we talk a little bit later about some of the drawbacks of WebSockets. So overall, it has a really nice promise of providing that really efficient data communication from the server down to the client in a bidirectional manner. So pushing back, up, down. So if WebSockets are great, why would Bitcoin Monitor use long polling? What about other sites that are out there right now? We have, Asana, for example, which is a really cool collaboration tool, which was founded by some former Facebook folks. We use that a little bit for communication, and which provides you, just go in here. Kind of like collaboration of, basically you can work with other team members, and basically whatever you added shows up in real time on the screen. So, however, they're not using WebSockets. Why not? Another one which I thought was interesting was Meteor. Kind of like a JavaScript framework in the cloud. They're more, at least for me, more famous since they were one of those companies that got like $11 million in startup funding, so which I thought was kind of cool. I need to get that. But they're using actually Sock.js, which is it's an abstraction library for WebSockets, and but they disabled it by saying like, hey, it's inefficient for various browsers. Also, browser support. It's getting much, much better. So pretty much every modern browser now supports WebSockets, including IE10. Woohoo! Finally. However, there's still some issues, for example, even in the mobile space. I mean, we have, for example, Android browser doesn't support WebSockets. So my understanding is that the latest 4.2 Jelly Bean now supports the Chrome browser. Is that correct? And that should support WebSockets now. But how long does it take before everybody's on Android 4.2? So that's certainly a concern. But at least Microsoft's on board. So you have, at least in that regard, a fairly good WebSocket support now. The browser share worldwide, still slightly problematic. Putting up the latest numbers. If you only pull it up for November, I think IE was already in the minority. So so it's changing. But depending on your target audience, you may still run into quite a bit of restrictions of where you can use WebSockets today. If you look at certain different locales on the planet, maybe you need to do business with China. Looks really depressing. What's even worse is this number even gets worse, because when you look at those some of those browsers, my understanding is that 360 Safe browser, Sugu, those are also all using what they call the Trident engine, which powers IE. So you may run into similar issues there as well. So that number goes even higher. But at least they finally get rid of their IE6. So for the longest time, China still had plenty of IE6 browsers out there. So there's still a certain percentage of those there as well. So something to keep in mind if you want to use the latest and greatest stuff. Browser versions. Chrome certainly seems to be the lead these days. Still a little bit of things tapering up, but even there, IE8, IE9, IE10. When I checked, didn't even show up in any of the stats. So maybe next month. Let's see. But just something to be aware of. HTTP proxies seems to be a problem. So they do content caching, buffer data, but they're not for long-lived connections. And so you may run into issues with proxy traversal when dealing with WebSockets. This is kind of like a statement on an InfoQ article by somebody from Kazing. And Kazing is one of the companies you may take an eye on. They're really big in the providing commercial offerings in the WebSocket space, some solutions in that regard. So so they really know what they're talking about. And they were also on the, I believe, on the WebSocket spec. So today, most transparent proxy servers will not yet be familiar with the WebSocket protocol, and these proxy servers will be unable to support the WebSocket protocol. So depending on what environment you deploy applications, potentially something to be aware of that you may run into. So just some issues you may run into. For example, like when you establish the connection of a WebSocket, that you retain that connection header. Also that that proxy servers may try to inspect the data you're transmitting. So, and since WebSockets doesn't really look like HTTP traffic, so that becomes an issue. Some of the WebSockets traffic, some of the older versions also had some security implications, because apparently, I didn't know, apparently there's so many faulty and buggy proxy servers out there, so that's something to consider. A few rules of thumb. When you do WebSockets, they support also, similar to HTTP, HTTPS, there's also a secure version of WebSockets. So you should strive to use the secure version, which with the WSS scheme. that seems to provide better proxy traversals, particularly since the proxy servers are not able to introspect your proxies. So you should use those. So technically, proxies shouldn't have a problem. They can be configured to work with WebSockets, but they may not be. So put that out there. Also, when you're dealing with WebSockets, they sound great, but once you start looking into smaller little details of keeping connections, for example, alive, internet is inherently unreliable. Anything can go away. Your server, your client, worse when you're on the cell phone. You're driving in a tunnel. What happens when your when your connection drops off? How you establish it? So all those little good stuff. Also, how to dealing with keep alives. You basically do a ping. A pong comes back from the server. Heartbeat. I'm still here. Message delivery guarantee. You're sending a message. How do you know that your client got it? May not matter to you. Might cost you millions of dollars if it does not. So who knows? Buffering of data. So if you're sending stuff from the server to your clients, what happens if the client is offline? But when he goes back online, you would make sure that that particular client gets the data versus other clients that already got it. So something to consider as well. So let's start with a little bit of history in that regard. Actually, it all started with Java. So Java applets were able to kind of like do socket communication back in the 90s. Then we had 1999, 2000, thanks to Microsoft. We got XHR and consequently AJUG, so that was cool. 2003, Macromedia and Adobe Flash, they had the RTMP protocol, so that was kind of like neat to exchange data, kind of like socket, kind of like WebSocket, basically like WebSockets over the wire. And even some solutions may still use it as a fallback in order to get data back and forth. So if any of you has done Flex of any sort of this kind of feels very familiar, and you're kind of like feeling like I'm back to square one basically, because we did all this stuff like years ago and it worked great most of the time. But Flash is dead, so moving on to WebSockets. So then came Comet, which was coined by Alex Russell. I have a link to his blog post. Kind of like AJAX, just had too much time, thought about this term. Comet was born. Event-driven server push data streaming. Gmail's gTalk was one of the ones that used that first. All kinds of hacks around that. Using long polling. There's like HTML file ActiveX object, all kinds of different weird hacks. You can basically make that work across browsers. So one thing I would like to mention in this regard, though, is server-sent events. So when we're dealing with WebSockets, and already mentioned a few pitfalls you may run into. However, you would like to just push data, and you really don't care too much about the efficiency of getting data back, or maybe just doing a post back to the server. HTTP post will be perfectly fine in your situation. You may would like to look at server-sent events. So that's also part of the HTML5 spec. Look into that one. Works over HTTP, so shouldn't have any of those pitfalls. Support is great across browsers, except for the one Microsoft. So don't. So if you can live with that, that might be a good option to look into as well. Then in 2007, Ian Hickson, who's also worked really big in the CSS spec, HTML5 spec, so he's a really big name in the web space. He basically put out like a TCP connection API and protocol, kind of like the earliest precursor information related to what we know today under WebSockets for bidirectional communication. Not that much more information I could find on the internet, but it exists. So I guess when it's on the internet, it's true. But WebSockets first public draft in 2008. So damn, that's already 4 years ago. So it's getting old. And then it goes through IETF standardization, first through the network working group. We have all kinds of different draft versions, and I wanted to mention those draft versions here, like HIXY 75, 76, etc. Because if you look some of the postings on the internet, you may still happen to find libraries or articles, etc., that are referring to specific versions back then of those draft standards that were enabled in various browsers, and that are not necessarily applicable anymore, but it's still, some of the stuff is still out there. Then we have the HIB working group, which also did right around that time was when there was like that one security flaw that, or theoretical security flaw that was discovered with the then existing draft of the WebSocket protocol, and I think that was also around something proxy related. I forgot. And then eventually we got to December of last year, RFC 6455. Good read to fall asleep, but very, actually not that bad. But that's we have the final WebSocket specification out there. So now we can go all and out there, implement stuff, use it. I have a link here for the spec itself. So as I mentioned, TCP-based protocol, bidirectional, full duplex, the status code is 101. It can not only do text frames. So most examples out there will always use, hey, we transfer JSON back and forth, but you don't have to. So you can also use it to transfer binary data. And I think that was one of the changes throughout the drafts within the WebSocket protocol development, that you can also send binary data. You know, different schemes, unencrypted, WS, and encrypted is WSS, and use the encrypted scheme if possible. There is one thing that kind of happens when you establish a WebSockets connection, is like that this WebSocket handshake. So basically, the client establishes the connection, you know, basically sends an HTTP request back to the server, and sends basically a key back to the server in order to make sure that, you know, that you trust the server, etc. You're sending that little key over there, which is that 258E, etc. You then the server then appends it to a key plus a SHA digested and base64 encoded, sends it back to the client. So basically, to establish that connection and that you can trust a trustful connection between client and server. Talking about a little bit about the WebSocket protocol details itself. So I mean, it's a little bit like going down to understanding the TCP protocol. We don't really care today anymore. I mean, unless you're really in that socket space. But you know, if I do JSON over REST or so, typically I don't care about TCP. And probably if you later on do real work with WebSockets or some of the abstraction layers on top, you probably will never really care about the protocol itself. But you came to my presentation, so at least this is the one spot where you can learn a little bit about it. Basically, we have like the first bit basically indicates if this is like basically when we send messages, you can send it just fragments of the message. You can split up messages into various fragments that are being sent over the wire, and you can basically indicate with this one if this is the final the final fragment that belongs to that one particular message. If a few areas for reserved for extensions. We have the opcode. It's basically indicating if are you dealing with a text frame, a binary frame, or are those control frames, which I'll talk in just a second, or if this is a continuation frame, so that basically you're hitting a frame that belongs to a previous frame, so you know multiple frames form a message basically. We can do a mask. So basically, clients need to mask the data. So that was another reason, I think, that was one of the changes throughout the draft in the WebSocket protocol, that apparently some proxy servers, if you wouldn't mask, they would be, apparently you can hack those things technically by passing real HTML data or whatever HTTP header information, etc., within your packets, and the proxy server might actually interpret that data. So so clients must mask, but the server response may not. Then we have the payload length. So we have various indications, 7, 16, or 64 bit. Basically what the length is of my message. And then basically we have, following that, we have the payload data. So it can also be extension data itself. So so you can, basically the protocol itself also provides means to provide extensions and also subprotocols. But let's talk first about the control frame. So basically what we have, they basically express the state of the WebSocket communication. So is it closing the connection? Is it a ping, a pong? And there are multiple more possible in the future. So there's but typically close, ping, and pong. Those are probably the most important one to keep in mind for WebSockets. The close frame basically terminates the WebSocket connection. It can contain actually a textual information in it. You, as from the browser perspective, have no clue what that means, but it's in the spec. So technically, if you do server-to-server communication, etc., you have maybe access to it, or maybe later on it will be exposed some way or the other. But it's at least possible. You also have different status codes. There's a whole bunch of lists specified in the protocol. Normal closures, that the endpoint is going away. So different error states you could actually communicate via WebSockets as well. We have the ping and pong, serve as a keep alive, followed ping followed by pong. So that can be technically used to, basically keep that the client is still that the endpoints are still there. So you can just send pongs basically to serve as a heartbeat. And keep that thought about ping and pongs for just a second when I talk about the JavaScript APIs. So we have those technically in there in the protocol. We have possibly extensions in there, so there are various extensions in draft status right now. At least in September there were. I'm not sure if anything of them went final since then. That was one thing I didn't check. So for compression, one thing I would, for example, is for the multiplexing extensions, MEX. So that's, for example, if technically what you would like to do is only do one WebSockets connections, actually even per browser. So you could actually, so that you technically share the same WebSocket connection to a server across, not just within your same tab, but also technically across even the various windows you have in your browser. So so that's basically what Mux could do, so that you technically only open one connection. So so that's something to keep in mind. And you basically establish those when you open up your WebSockets connection. So yeah, Mux. Then there are subprotocols. So I mentioned that you can have basically WebSockets only provide you some raw communication means, but as I said, your connection may go out. You may want to have reliability. You need to ensure that whatever messages you send from the server to the client and vice versa are actually there. So you potentially may be interested in some kind of like transactionality, etc. So that's where subprotocols are coming in. And this is kind of like where the where things are really just starting to develop. So this is not that much has been done yet, but I would expect that over moving forward that you will see more subprotocols coming out for WebSockets or running on top of WebSockets. So there's a IANA registry where you find all those subprotocols registered. So there's one for Stump, WAMP, which is kind of interesting. They actually provide the WebSocket test suite that many projects out there use. So they're They're quite active in that space. And this is not an April Fool's joke. There's actually a soap. And I'm not saying which company that is again. You could probably guess that. But why would you do that? Seriously. That's just evil. When we talk about WebSockets in the case of HTML5, we typically don't really mean necessarily the WebSockets protocol, but we rather like to talk about the API by the W3C. So overall, conceptually, HTML5 WebSockets protocol plus the W3 API together. That's something to realize. That one is still is a candidate recommendation as of September. There's a link out there. It basically provides a browser client-side API. So so that browsers you can within your JavaScript write stuff, establish WebSockets communications to your server side. Supports binary data as well, so you can do blobs, array buffers, and you can have some means to inspect the extensions. However, there's no means of providing ping and pong. So what I said that, well, technically it would be kind of cool to have those kind of heartbeats or keep alive within WebSockets. There's currently no way to have that available to you from the raw protocol perspective. So you would need to implement those on top using those sub-protocols, for example, with WebSockets. So you may have to do that more specific from that perspective, so they are not available to you there. You have a very kind of like when we do AJUGs, various attributes to connecting, open, closing, closed. We have various event handlers we can tap into when we do the JavaScript communication, establishing a socket, new WebSocket, localhost, connecting to the server, and then basically connecting to the on message, and we can parse the data that's coming back from the WebSocket. So fairly simple, not that much to it. And yeah, take a look at these samples that they have. That's taken from one of those. So, having gone through the JavaScript side and the protocols perspective, so what about Java? Just want to mention in this case, since I'm talking about the very standardization efforts, so there's a JSR out there, JSR 356, Java API for WebSockets. Latest draft review, December 2012. There's a link to it, and I will talk about it when I talk about the various implementations that are available in just a second. But let me talk first about non-Java solutions. The reason why I do this is there's basically, when you look into the development of HTML5 and WebSockets, or just generally, there seems to be a little bit of a notion that people seem to implement those rather these days on Node.js than, let's say, in the Java world. So we're kind of like behind a little bit in terms of implementation of the various APIs as well as libraries available to us. So when you do WebSockets, and then also some of the fallback options that are provided by Socket.io and Sock.js, you had those available for quite some time now on Node.js and JavaScript. And slowly we see those trickling down implementations also on the Java world, but a little bit slow. So we talked about WebSockets. Node.js have native WebSocket support, but what about Socket.io and Sock.js? So I talked about, when I showed you that little view of browser penetration, that you may, plus proxy issues, etc., that you may not rely fully on WebSockets. So it may work most of the time with your clients, but not always. So basically what Socket.io and Sock.js provide is kind of like different fallback mechanisms from within your, and they're basically JavaScript libraries that allow you, if the server supports SockJS or Socket.io, that you can use fallback options, which basically means long polling, for example, flash socket, etc., just polling, etc. So there are various degrees of degradation that they provide when you establish bidirectional connections from your web applications. So pretty cool. So that's kind of like the notion of that you would probably use something like this rather than possibly the raw WebSocket communication, at least for the time being, before the WebSocket space kind of matures. So we have Socket.io. I put here in also Engine.io. So it's kind of like Socket.io provides a whole bunch of stuff on top of just pure fallback options. But so they kind of abstracted that one out a little bit. So it's Engine.io, which is kind of like more directly comparable to what SockJS provides. And kind of like a little list of some of the fallback options that Socket.io provides. SockJS, a couple of its fallbacks. So also, depends on like different, like the some of the older WebSockets implementations and older Chrome browsers. And interesting question is always like what to use when you talk about Socket.io versus SockJS. So for the longest time, Socket.io was actually the oldest of those libraries that was out there. And SockJS came about as kind of like the little bit newer, a little bit fresher, a little bit more, supposedly more efficient. And SockJS focuses more on purely on the transports versus adding some of the added stuff that Socket.io provides. So there's a little discussion thread that talks about pros and cons. It seems to be that SockJS seems to gain more ground versus Socket.io. So something to look into if you develop your own solutions projects, one or the other. For example, the Bitcoin exchange we're using to get data from, they also provide a Socket.io API, but not a SockJS API to get data from. So certainly a very dynamic space. And there's also some efforts to actually standardize the API or even the protocol of how SockJS or Socket.io works. So where we are with all this stuff in the Java world. We have across browsers rudimentary support for raw WebSocket support. So Tomcat has the WebSocket servlet since Tomcat 7.027, March 2012. There's a backport issue, but hasn't seen any activity lately. Fairly minimal implementation. Link to the how-to. But always keep in mind that all those efforts are probably going to change quite dramatically as the JSR, the standardization matures. So lots of the stuff is like super highly in flux. But let me show you the Tomcat example. Tomcat servlet, okay. Just restart the app. All right, we should see some data coming in. Hopefully in a second. Yep, here we go. Published rate. So the way we implemented the sample is basically also to illustrate you a different way of thinking about WebSockets. So whenever you start learning about WebSockets, it's typically browser communicates to a server, but that does not have to be. So it can be server-to-server communication as well. So there are certainly some interesting use cases in order, for example, to avoid opening firewall ports if you need bidirectional communication between two server instances, etc., where WebSockets could potentially play an interesting solution. So in this case, what we do in our application is opening up a WebSockets communication from the server to the Bitcoin exchange, stream the data from there back to our server, and then stream it back down to the connected clients. So let's go into the browser. Bitcoin RT, refresh. We got the switching protocol, and we see the first trade coming in. So everything works. Cool. So same as the Node.js implementation. Not that much else to see. We have from server broadcast, we have the Bitcoin servlet. You should see some yeah, got text message, broadcasting. So take a look at the sample to familiarize with it. I just don't want to get too much into it, since it's literally, you probably, unless you guarantee that you only would like to work against Tomcat, for example, or some of the other servers, it's probably going to change quite a bit in terms of the API, so how those are currently implemented. In Jetty, we also have early support for WebSockets, uses for Java 7. You have also access to the messages, so check that out. Got changed in NetJetty 9. Glassfish has WebSocket support. The big takeaway is probably just that also, like, they all kind of like slightly interpret the way how they expose the WebSockets on the server side. You know, just the messages. Do you get exposure to the frames, or even potentially some of the control frames, etc. So that varies from implementation to implementation. But most likely you may look at some of the other implementations that are listed here. So particular like Atmosphere, that's probably right now the most prevalent in the Java space, providing all kinds of different fallback options, working across also different application servers, from Tomcat to JBoss, etc. So they provide support for that. Different web framework support is also provided via Atmosphere. I can show you a quick example of Atmosphere right here. Let me close that, remove the application. Then Bitcoin Atmosphere, put that out here, deploy, boot it up, and hopefully nothing bad happens. And we should see also here data coming through, I think. Let's see. Bitcoin Atmosphere. Okay, we got the switching protocol, and also see trades coming in. So in this particular instance, if you would, either in the JavaScript, you can disable, basically set which fallback options you would like to do. So you can basically also experiment with different communication means to basically disable WebSockets, use a different mechanism. So they have support long polling, server send events, streaming, etc. So trades trickling in, and this sample here is actually set up using Spring MVC. So let me just do a quick dive in here. We have a controller here, home controller. Just it's a little bit bigger. Nothing too fancy here at all. I'm basically injecting an atmosphere resource here that you can set up using an argument resolver. So you can plug that in to get that to basically get the injected into your controller without having to do any kind of like more nasty looking utility methods. Then I'm basically delegating it to my little utility method over here, getting and basically suspending the atmosphere resource. So basically when I get my request in, and this is kind of like where atmosphere, you know, they kind of like trying to merge the request response model with the WebSocket model. So that's not necessarily like a big fan of that, but that's the way they operate on this. So you then basically add your event listener, where you can you know, on suspend, disconnect, on broadcast, your broadcaster factory, kind of like little something to work around when you do long polling. And that's pretty much it in this regard. We have we have the Bitcoin client. So in this case, the async HTTP client that basically goes out to the Bitcoin exchange, which is basically in this case a WebSockets connection to websocket.mtgox.com. And we have various listeners connected, unsubscribing, and then basically sending our getting a handle on the WebSocket and basically sending messages. So take a look at those samples as well. And that's pretty much it. The setup that's interesting in when you're dealing with Atmosphere as and set that up in your application is that you basically wrap the your Spring application context setup. So if you take a look at source main, web app, webinf, use, where's my, oh, sorry, I forgot. I set this one up actually using, I guess old habits never die. Basically, you don't have to use web.xml anymore with the latest servlet specs. So in this case, I'm setting up my Meteor servlet. So that's what Atmosphere uses, and adding my Atmosphere handler. So listening on everything. And this will also, where is it? Basically, the Atmosphere handler itself will also wrap the Spring application, your web, your Spring servlet basically. So it basically injects the Atmosphere resources, so you can get a handle on those those information. So it's a little tricky there, but overall, it's probably the best solution we have right now if you need to provide broad WebSocket communication, but also with fallback options, with certain degrees of transferability between application servers. So that's the best, in my opinion, one of the best options we have right now. However, it's not the only option we have. There's a couple of other WebSocket specific implementation out there, like JWebSockets. Netty has one. Grizzly. I want to specifically mention Vertex. So that's basically a Node.js implementations on the server side And it provides really nice WebSockets connectivity as well. Let me just probably go in here into the Vertex example we have. The funny thing is that in this case I have an embedded sample of Vertex running here. So so typically you can run Vertex as a standalone implementation, kind of like Node.js. But you can also embed Vertex itself into your, kind of like what you can do with Jetty or Tomcat within your main method in Java. So I have my Vertex bean here, which will bootstrap a new Vertex instance. Also provide basically a SockJS server in this case, Bitcoin. Then I'm starting the client from Vertex, so Vertex itself has I can create an HTTP client, goes out to the Vertex exchange, to the Bitcoin exchange, get the data, streams it back. So that's another option. You can provide WebSockets communication within your Java application. So technically, you could embed Vertex even into your WAR deployments and basically spin up another Vertex instance within your WAR. The problem, though, is it uses its own port unless you're doing your own routing in front of your web applications. I tried actually to experiment, let's try, for example, with the URL rewrite filter, which provides, which is a nice library in the Java world that allows you to, via configuration, do rerouting of requests to other endpoints, either be it external to your deployment or just to different ports within your server instance, and basically trying to reroute as kind of like the basically proxy connections to the Vertex port, but it failed actually. So that was another example of you have to watch out with proxying, I guess. But if you don't mind having Vertex running on a different port than your normal 8080 or so, you may deploy also in the same both in the same application if you wanted to. So let me. Vertex. Okay, we have it. This one's running also as a WAR deployment. Let me just remove. Vertex embedded. Tomcat. All right, boot this up. Looks like it's starting up. All right. So go back in here. Bitcoin. What do we have? Bitcoin Vertex embedded, and yep, in this case also builds up a connection, but in this case my JavaScript extra will connect via oops, one second, jQuery bootstrap SockJS Vertex bus. Where did I? In this case, I'm basically connecting over to on port 777. Interestingly, if I would use actually the port, basically I have this sample comes also with that URL rewrite set up, it would actually fall back to long polling. So it basically illustrates using SockJS. So even though this WebSocket communication doesn't materialize, you then end up using long polling to provide that same functionality. All right. On the client side, so as I mentioned, we not only have browser to server, but also client doing other WebSockets communication. So there's async HTTP client. That's probably that we use in our samples, Jetty, Netty, Vertex, Grizzly. So a couple of implementations that are out there in that space. However, those are WebSocket specific. So if you would like to have like a Sock.js or a Socket.io client in the Java world, things are getting a little bit more wiggly. I had, for example, for Bitcoin exchange, I was looking for one for Socket.io, and that was tricky. There is one out there, but it doesn't really provide any. It's not in the Maven repositories. You have to probably get it to work, but I'm not sure if it's production ready. So we have the Java API for WebSockets, JSR 356, still heavily in flux. Will not depend on the Servlet API, so particular since in Ocean you can use it also as a client API. So it will provide client and server APIs. Will use annotations, but also allow for use the API directly. It will have support for extensions. Also will have security considerations in there. However, based on my reading, kind of like your security starts where you basically establish the connection. So when you have your, you basically it assumes that you have an authenticated request establishing the WebSockets communication in there. So the latest spec was released 2 days ago, I think December 15th. Take a look at the draft reviews, the mailing list, quite active. So it's heavily in flux. So I don't really want to get too much into the deeper end. So if I would probably do a presentation in a few months, etc. I would probably provide more details on the Java world, but it's coming. So and you will also see Spring support for the JSR itself in the next version of Spring. So it's certainly, we just released 3.2, so the next version. But it's in flux. Some really super experimental side from our side. So this is kind of like our team working on the Spring integration side. I'm still need to find my time to get my Atmosphere extension out there. So also we have considering adding client support, for example, for Sock.js. So basically, Spring integration provides you an ability to, implementation of enterprise integration pattern, and it's very useful. It also provides communication adapters to basically connect to external systems, etc. So that's kind of like where we connect in that world. Well, we probably also have need to have a story in regards to WebSockets, as well as some of the abstractions on top, such as Sock.js as well and Socket.io. Event bus support. So that's something, for example, Vertex has. So in Vertex, you can actually send messages to just an identifier string, etc. My bus 123, and any kind of connected client, be it on the JavaScript side or other connected Java clients or Vertex clients, will get that message. So it's kind of like messaging across. Basically down to your browser clients as well as other clients. So that's something that really intrigued me also on the Vertex side. So that's probably something you will see moving forward as this whole WebSocket story evolves. That you will see more implementations of higher level protocols on top, which includes messaging. I mean, technically, maybe even, something like JMS, AMQP, etc. Will have connectivity. Interaction with WebSockets eventually. We have one interesting demo, my last demo I have, which was, we have, in Spring integration, we also have probably somewhat underappreciated also TCP adapters, TCP IP adapters. So you can actually opening up sockets within Spring integration, get and basically listen on that port, receive messages, etc. So fairly low-level support for messaging there. But a colleague of mine, he implemented kind of like serializers for WebSockets on Spring integration. So this is kind of like a super early, very experimental at this point. So certainly I would advise anybody to use that in production. Heavy disclaimer there. But it's at least possible, so that it leaves some room for experimentation, and maybe something will evolve out of that. So we have the IP extensions. The way it works is basically I have my my context file, and I have basically my TCP connection factory, and then I have my inbound channel adapter, so kind of like concepts within our Spring integration world there. And then I basically provide a serializer here, a WebSocket serializer that implements basic elements of the WebSocket protocol. So if you want to go nitty-gritty into how the protocol works, that might be an interesting space to look at. And then basically we provide WebSocket server test. Let me spin that one up. Let me close this. Run the test. Java application. All right, looks like it's up. And Spring integration. So this one is the only one that doesn't use Bootstrap. So the graphics is not. I didn't have the time to put that in there. But we have WebSockets connection is established. WebSocket protocol handshake, Spring integration, send to Spring integration start, and we should see the counter basically going up here, counting up. Nothing really spectacular. However, if you go if you take a look at the data itself, the frames, basically all we do is sending numbers that are counting upwards, basically sending over the wire. So if you need to have, if you have low-level TCP requirements, take a look at Spring integration. Certainly a nice experimental way to get WebSockets support in there. Would be interesting to see where we take it from here. So just want to show you that little example here. All right. Oh yeah, and interestingly, if you haven't watched it yet, we start having more JavaScript stories as well. So there's a new repo, Spring there's like a framework for integration.js, but there's on GitHub there's a repo now for S2JS, so which has basically Spring sources, JavaScript projects hosted, so that you will see more projects, more efforts on that side as well. Let's continue. So building a few conclusions. What's the read time wise? 8:22. Cool. So WebSockets technology is certainly promising. And as you hopefully learned in this presentation, it's not the silver bullet. Certainly has its drawbacks. Still evolving story. Look at the if you would like to use it, look at those limitations mentioned and kind of like see how it would fit into your requirements. It's potential replacement for commit techniques, but if something like server-sent events fits your needs, take a look at those. The need probably for fallback options probably still persists for some time. I don't know how to make those predictions. It took forever to get IE6 out of the game, so who knows how long those proxy servers will be out there. Or finally, browser. All the browsers will support it in a meaningful fashion. I mean, even like the when you looked at the command in Meteor, something that I haven't really touched too much in here is how efficient are those browsers, even if they support WebSockets. This one comment was like, hey, maybe your fan is spinning up, or battery consumptions on your devices. He said it might be something to consider. So integrating WebSockets into your real app might not be as trivial as maybe your simple Hello World WebSockets example suggests. So, but time to think about it. Pure WebSockets, probably unlikely. So probably rather having those additional abstractions on top of it, including sub-protocols, different messaging solutions there. But hopefully at least the fallback options will diminish or somewhat fade out over time. Sock.js, probably the most promising effort right now in terms of those abstraction libraries. But it's still super in flux. I mean, usage pattern. I mean, what would you use, for example, WebSockets, right? I mean, everybody uses REST. However, you could technically use something like what, if you do done Flex, where you basically use the Blaze.ds, for example, to connect to your server in a bidirectional fashion, that you could just technically hit Java services or, just bypass REST altogether and just use execute business service directly on the server side. Is it a good idea? I don't know. I mean, REST certainly probably here to stay, not being replaced, and it's kind of like a complement, but depends on where people are starting to use WebSockets for various possibilities. I mean, gaming certainly has some we really need that low-level applicability for our business applications. Probably for the vast majority, REST will be the predominant way moving forward. So probably not a need to switch down to that level. Also, if you consider using WebSockets or have those kind of requirements for your application, you may want to look at commercial vendors that are out there. Kazing certainly is probably the most predominant out there. They work on this spec, have a really good website actually, websocket.org. That's a really good WebSocket resort. Take a look at that. If you're doing mobile, I mean, that's another one. You got all squared up. You're feeling really hot doing WebSockets, got everything squared away. But what happens if your mobile device goes to sleep, etc.? How do you resume your WebSockets connection? I mean, in this case, you may actually want to look into certain push notification service, APNS for Apple or Google's cloud messaging for Android, so that you basically, in order to wake up your services, let's say your application went to sleep, etc., you would like to resume your application, that you basically send a push notification with some IDs, etc., kind of like the claim check pattern, that you basically wake up your device, resume your application, and then resume your WebSockets communication or etc. to basically continue processing data or so, whatever your business use case is. In this case, you may want to actually look at, for example, Urban Airship, as they provide, since running those kind of push notification services yourself, it's not a trivial issue. There's a Spring Mobile support for that one out there. Just wanted to mention it. In the Java world, JSR 356 certainly important to keep track of. So that's probably everybody will standardize on that level. Question will be seen though, as I mentioned, that you have it's such a low-level API in the sense that, where I said, like, you may not use WebSockets directly, that it will behave almost a little bit like the Servlet API. It's there. You probably have to use it occasionally, but it may not be a predominant way of how to interact with the APIs itself. So maybe more for higher-level services that will rely on those on the APIs provided by JSR 356. Atmosphere. That's probably, as I said, probably the best option right now. Dedicated Spring support in consideration, planned next version of Spring. So see the story evolving in that regard, probably towards the end of next year. And with this, I miraculously made it in just in time. So questions, anything you would like to see more deeper?
Question.
Yes?
Does the WebSocket protocol handle the reconnection? So if I get interrupted for whatever reason, will it automatically reconnect, or is that the protocol above its responsibility?
That will be the protocol above. I'm not sure if the browser itself will do a little bit of that kind of stuff, but technically would be your responsibility to reestablish the connection. So I know that, for example, Atmosphere has certain reconnect policies you can basically set in motion of, like, how often you try to basically reconnect to the server side. So yes.
Talk briefly about the thing in the phone. How does that differ from the TCP, TCP/IP, and TTL that they have that's already known the connection between those two?
The spec certainly doesn't really mention that, so I couldn't elaborate on that.
It's very well possible that the TCP connection, the actual time to live and TCP/IP that pings at the lower levels could actually time out before your WebSocket did and would drop your connection before you simply routing on top of the TCP layer.
Good question. I don't know. That I couldn't elaborate that. So it's not on the, certainly not in the spec itself how that, and that question I never came across actually when I looked through the when I did my research. So I need to look at that one. Other questions?
Have you ever looked at Comet D? The Jetty guys?
It's, yes, I briefly looked into that one. The problem is just, particularly when you prepare for presentations, you almost have to cut out stuff. I mean, there's just so much stuff out there that's not even funny. I mean, there's all kinds of different frameworks. As I said, like on Comet, on those push technologies itself, there's like a whole bunch of activity as well. So I noticed them, but I haven't really looked deeper into them. So there's some viable frameworks, solutions. As you said, Comet D is probably the pretty prevalent one out there. But
you mentioned Atmosphere, and they're kind of neck and neck with regards to adding features to try to help do the other one. Something I've come across.
yeah, that's probably one notion I'd probably say about Atmosphere. It tries to be, in my taste, has too much of a broad scope of trying to cover all kinds of different frameworks, and it's at that point then difficult to find actually exact answers to my specific needs. So, for example, for the longest time I had problems actually to get it to work nicely with Spring MVC, for example. Luckily, the documentation, etc., starts to get much better over the past few months. So it's not as depressing anymore. But yeah, that was certainly my notion as well, that trying to do sometimes maybe too many features, and then you run into bugs, etc., all kinds of stuff. So that's something to keep an eye out.
Is the JSR going to be anywhere near done in, let's say, a year, or is it still like
Java EE 7.
Okay.
7? Yeah. So it should be in next year.
Okay.
So so that's basically where ours. Basically, the next version of Spring will then basically be piggyback on whatever the full release is. So, but we still need to figure out what do we just provide pure WebSocket support, or actually provide also abstractions on top of, to basically provide something that's useful in the current for practical implementations.
WebSocket template?
While you mentioned it, there's actually a REST template now for JavaScript. So
Yeah.
so yeah. Yes.
Could the sites look at like practical implementations of how this could really push back to the browser?
Probably a good resource, probably generally about any of those HTML5 resources, probably HTML5rocks.com. That they have some pretty good also tutorial and also reading material, including WebSockets. There's a really nice article on server-sent events there as well. WebSockets.org also has some good resources. So there's certainly lots of stuff out there.
Do you know anybody who's actually pushing back a DOM node back to the, like let's say you get data from somewhere else, and your browser is talking to the web packet. Can you then push back a whole DOM back to, anybody?
You pretty much can push back anything you want. I mean, that's kind of like the nice thing about the WebSockets itself. I mean, it's binary text data. You basically define whatever you want to send back. I mean, whatever you define, including binary data. Yeah. So you can, if you want to send back images, etc. So you could do that. more questions? Anybody used actually WebSockets or created played examples or experimented with them? Nobody. Nice. So that's kind of like the. Huh? Okay. So yeah, Node.js is certainly kind of like the all the cool kids are using Node.js these days. So so we're finally catching up a little bit on the Java world. So.
So unstable with Windows, I don't know why. They have a very stable build with Mac, but not with Windows.
Yeah, that's kind of like the problem. It seems to be like sometimes these days. I haven't. I mean, I'm kind of bitching about now the Apple fanboys, but I'm using it myself. But yeah, it seems to be like this notion of like all the lots of the stuff is like runs on Linux or Mac very well, but it's some of the stuff may bypass the Windows side a little bit. So all right. So if this was it, I would hopefully this was useful. Provided some valuable information to you. Please check out the samples, play with them. The presentation slides out there on SlideShare. I can ping it also to the mailing list. So, so with that, thank you very much for coming.